You live on a quiet planet wrapped in blue oceans and warm air, circling the sun at just the right distance for life to breathe. Most nights, you don't think about where Earth is in the larger map of the universe. You go to work, you come home, you rest. But tonight, something is happening far above you, in the same sky you've stepped under your whole life. It isn't loud, it isn't dangerous, it doesn't shake the ground or change the wind. It's quiet, almost impossibly quiet, and yet millions of miles above the clouds, it's unfolding in real time, in the same universe where you are lying right now. A visitor from another star system is approaching Earth and turning off its lights. You may not see it from your backyard or through your bedroom window, but every night, telescopes across the world are following that faint dot as it drifts closer to the inner solar system. They follow it because it's rare. They follow it because it's unpredictable. But they also follow it because this object, this interstellar traveler, keeps breaking the rules that every astronomy textbook you ever saw tried to explain. And you, sitting here at the end of your day, click this video because part of you wants to know what that means for Earth, for you, for all of us sharing the same sky. Before we begin, take a breath. You are safe. Nothing out there tonight is coming toward your city or your home, but something is drifting near your world, near enough to study, near enough to notice, near enough that, for a brief moment in your lifetime, your planet and something from another star system are passing close enough to exchange light. And that alone is worth paying attention to. The first strange thing that happened was the dimming. Normally, a comet brightens as it approaches the sun. Heat creates gas. Gas creates glow. Glow creates beauty. But 3i Atlas refused that script. Night after night, its brightness curve slid downward as if someone were slowly turning a dial. For you, the dimming is more than a scientific anomaly. It is a reminder that not everything becomes clearer the closer it gets. In life and in space, sometimes the truth grows quieter before it reveals itself fully. Then came the anti-tail. Comet tails are supposed to stream away from the sun, blown outward by solar wind. But on certain November nights, observers watched a thin line stretching, not away from the sun, but toward it. A tail pointing the wrong direction. A piece of the universe quietly disagreeing with the rules you grew up with. And maybe there is something comforting there too. The idea that even things older than civilization can change direction when conditions shift, and that what looks like wrong behavior may turn out to be a different kind of right. Not long after that, the sun reached out. A burst of charged particles, one of those storms most people never hear about, washed across 3i Atlas. It should have shaken the object, fractured its surface, scattered its dust. Instead, the comet absorbed the hit like a stone in a river. It dimmed a little, shifted slightly, then continued on. There is a kind of resilience in that, a quiet strength that doesn't announce itself. Maybe that's why people seem pulled toward this story. It behaves like something that has traveled too long, seen too much, and learned to endure without making a sound. But the most puzzling piece came last, the speed. After the solar flare passed, small changes in the object's motion began to show up in the data. Not dramatic, not alarming, but unmistakable. 3 Atlas started drifting faster than it should have. A subtle acceleration where there should have been none. And here too, the universe whispers something to you. That even ancient travelers can surprise you. That momentum can come from unexpected places. And that not every shift is a sign of danger. Some are signs of complexity. All of this is happening above your head, above your home, your family, your country, your world. As you breathe in this quiet moment, this traveler from another star system is moving through a sky your ancestors stared at long before telescopes existed. The same sky sailors once used to cross oceans. The same sky farmers once trusted for seasons. The same sky you stand under when life feels too small or too heavy or too fast. This isn't just a story about a comet. It's a story about Earth, your Earth, sharing space with something foreign, ancient, and fleeting. It's about watching the universe change shape in real time. And it's about understanding that mystery doesn't always mean fear. Sometimes it means you're paying attention to the right things. Tonight, you and billions of others are living on a planet that happens to be aligned with an interstellar visitor. You're watching dimming, anti-tails, solar storms, and shifting speeds through the lens of someone who wants clarity, not panic. And before this night ends, you will understand why this moment is rare, why this traveler is strange, and why none of it threatens your world. So settle in. Let your mind lift a little above the day you just lived. Let your breath slow. Because the sky above you is telling a story. And tonight, it's your turn to hear it. If you clicked on this video because the words near Earth and dimming felt a little unsettling, you're not the only one. It's natural to feel that small pulse in your chest when you hear that something from another star system is drifting near the orbit of your own world. You live on a planet where danger usually comes with noise, speed, force, or heat. So when something quiet approaches from a direction no human history has prepared you for, the mind naturally reaches for the word terrifying. It is a word that sits right between fear and fascination. And you felt that when you saw the title. You felt both sides of it at the same time. But here's the first thing you deserve to hear clearly. Terrifying doesn't mean dangerous. Not tonight. Not with this visitor. Terrifying simply means bigger than your expectations. It means you're looking at something that existed long before Earth grew its first forests or oceans. It means you're about to learn something that stretches your understanding a little farther than usual. It is the kind of terrifying that mountain climbers feel when they look down the side of a cliff, not the kind that sends them running. It is awe. It is humility. It is the quiet realization that you are a small part of a very large universe. There's an important difference between the things that threaten your world and the things that just remind you of how big that world actually is. When the ground shakes beneath your feet, that's danger. When a storm shifts across the horizon faster than you expect, that's danger. But when an interstellar traveler dims as it approaches the inner solar system, that is not danger. That is mystery, a mystery that invites questions instead of panic. A mystery that belongs to the same universe that made you curious enough to click tonight. Scientists feel the same curiosity you do. They don't sit in dark rooms whispering about danger or something hidden from the public. They sit at computers and telescopes, staring at graphs and images and asking the same question you're asking. Why is it doing that? The difference is that science approaches mystery with patience, with instruments, with long nights of observation and quiet discussion. Fear tries to fill in the unknown with the worst answer it can find. Science waits for the right one. The truth is, you didn't click on this video because you thought Earth was in danger. You clicked because you wanted to understand something unusual before everyone else turns it into noise. You clicked because you're someone who likes to hold on to a question until it becomes clear. You clicked because when the universe changes shape, even a little, you want to know what that means. That instinct puts you in the same room as the astronomers themselves. People who enjoy making sense of things that don't fit the usual pattern. People who sleep better when they understand more, not less. And here's the heart of it. This mystery isn't here to harm you. It's here to teach you. It's here to remind you that the universe still has surprises left. Even for a species that has touched the moon and photographed black holes, it's here to show you that not all mysteries crack open with loud sounds or dramatic consequences. Some of them unfold gently, like dimming light curves on a quiet December night, or a thin tail pointing the wrong direction, or a pulse in the brightness that feels almost like a breath. Terrifying doesn't mean harmful. It means extraordinary. It means rare. It means you're paying attention to something most people on the planet will never take the time to understand. And the more you listen, the more the fear melts into something else, something steadier, calmer, and more satisfying. Something closer to wonder. Mystery is only scary until we shine light on it. After that, it becomes a story. And that's what this moment is. A story happening above your world, not to your world. A story about a visitor from another star system doing things no one fully predicted. A story about dimming where brightening should be. A story about physics behaving like poetry. A story that you now have the chance to understand better than most headlines ever will. So let the word terrifying shift into something softer as we move forward. Let it become a marker of scale, not of danger. Let it remind you that you're living on a planet where interstellar objects can drift close enough to observe, close enough to study, close enough to wonder about without losing a minute of sleep. To understand both the beauty and the strangeness of this moment, we need to meet the visitor itself. Before we step into the events of November, you need a foundation, a quiet moment to understand what kind of object is passing through your sky. Because this isn't just another comet drifting in from the outer edges of the solar system. This is something rarer, older, and far more extraordinary. It belongs to a category of travelers that almost never come close enough for Earth to see. They're called interstellar objects. An interstellar object is exactly what the name suggests. A body that was born around another star, shaped by another gravity well, lit by another sun, and then pushed out across the vast dark ocean between systems. Most comets you've heard of, Halley, Hale-Bopp, Neowise, come from inside our own solar system. They orbit the sun, even if the journey takes them hundreds or thousands of years. But an interstellar object does not orbit the sun. It passes by it. The sun bends its path a little, the way a strong wind might bend a bird's wings, but it does not capture it. And once it swings past, it keeps going. Out. Away. Forever. A one-time guest. Interstellar objects are rare. Not just uncommon. Rare on the scale of centuries. Your species has been watching the sky with telescopes for over 400 years, and yet only 3 confirmed interstellar visitors have ever been seen passing through the solar system. The first arrived in 2017, the second in 2019, and the third is the one moving past your world right now. You may remember the first one, Oumuamua. Even the name felt mysterious. It was long, thin, shaped almost like a shard or a sliver. It had no coma, no tail, nothing you'd associate with a comet, and yet it moved like one. It spun. It reflected light strangely, and as it traveled, it accelerated ever so slightly. Not enough to be dramatic. Just enough that the numbers didn't quite line up. People argued about its nature for years. Some said it was a shard of ice. Others suggested it might be a fragment of a shattered body. And a few wondered, quietly at first, then loudly, whether it might be artificial. Whether it might be a piece of alien technology drifting silently between the stars. Whatever it was, Oumuamua left more questions than answers. 2 years later came Borisov. If Oumuamua was a riddle, Borisov was the answer key. It looked like a comet, behaved like a comet, and died like a comet. It had a coma, a tail, and the familiar bluish glow of outgassing ices. It followed the sun's heat, evaporated, and put on a show exactly the way a textbook comet should. If Oumuamua was the strange guest who wouldn't say where it came from, Borisov was the polite visitor who arrived carrying a name tag. And then, in 2025, comes the third, 3I Atlas. 3I Atlas doesn't fall neatly into either category. It's the hybrid, part comet, part question mark. It has a coma and a tail, just like Borisov. At first glance, it even looks normal. But the moment you watch it closely, the strangeness begins. Its behavior doesn't match its appearance. Its brightness doesn't follow the usual curves. Its jets don't follow the predictable geometry. Its orientation shifts in ways comets don't typically shift. It carries the familiar signs of a comet, but the personality of something much more unusual. And the journey it has taken to reach you stretches across unimaginable distance. It didn't come from the Oort cloud or some icy reservoir at the edge of the sun's domain. It came from another star's gravitational cradle, drifted out of its home system long before humans existed, and traveled a path so long that scientists measure it not in miles, not in years, but in light years. Thousands of them. And now, after that entire journey through cold, empty darkness, it is passing by your world, the only moment in all of human history when anyone will ever see it. Its orbit is hyperbolic. That means it isn't coming back. Once it swings around the sun, it will continue outward, away from the planets, away from everything familiar, slipping back into interstellar darkness. You are witnessing a once-in-a-lifetime crossing, not just for yourself, but for your entire species. So what makes Atlas so special? For one, its brightness makes no sense. Instead of glowing more intensely as it nears the sun, it dims. Then there are its jets, streams of gas that shouldn't behave the way they do, launching at angles that challenge the geometry of normal comet physics. Then the anti-tail, that brief thin line pointing toward the sun instead of away from it. Then the strange, calm pulse in its brightness, rising and falling every 16 hours as if it were breathing. And then the dimming paradox. The closer it gets, the more its light slips away. When you put all of these pieces together, dimming, anti-tail, jets, heartbeat, acceleration, you begin to see why scientists are calling it the strangest of the three interstellar visitors. It isn't behaving like Oumuamua, but it isn't behaving like Borisov either. It stands alone, a category of one, a traveler shaped by forces and environments your world has never experienced. And now, with the foundation set, you're ready to step into the timeline that mattered most. The month when 3I Atlas broke almost every expectation astronomers had for it. The month when its behavior shifted from unusual to unforgettable. The month when the mystery deepened night by night. Now, let's step into November. The month when things truly became strange. Early November arrived quietly. No announcement, no sudden shift in the night sky. No headline strong enough to interrupt daily life. But high above Earth, past the jet stream, and past the thin blue shell of atmosphere, something subtle began to change in the light coming from 3I Atlas. It started as a small deviation, just a number slightly out of place on a brightness chart. Then another. Then another. And within days, astronomers realized the first mystery of this interstellar visitor was beginning to unfold. Its brightness was fading, not by a tiny amount, not by a margin small enough to blame on clouds, equipment, or calibration. The measured brightness of 3I Atlas had dropped by roughly 63% in the early weeks of November. 63. For something approaching the sun, that number didn't just raise eyebrows, it broke expectations. Because the closer an icy body gets to the sun, the warmer it becomes. The warmer it becomes, the more its ices vaporize. And the more vapor it produces, the brighter it glows. You know this instinctively. Even if you've never touched a telescope, you understand the idea. Campfires burn brighter when you add fuel. Lanterns glow stronger when fresh oil meets a flame. Comets become more luminous when sunlight hits their surfaces. That's the pattern you've been taught, the pattern astronomers have documented for centuries. Near the sun equals bright. Far from the sun equals dim. But 3I Atlas did the opposite. Every night it moved closer to the inner solar system. Every night it should have picked up a little more glow. And every night it dimmed instead, as if a hand were gently turning the brightness knob to the left. If you plot the data, the line looks like a slow slide downward. A decline that begins subtly, then accelerates, then settles into a steady fall. This wasn't a flicker or a momentary glitch. It was a clear trend. A comet approaching Earth shouldn't be turning off its lights. To understand why this was so unusual, it helps to picture the textbook version of events. When sunlight hits the ices on a comet, those ices turn into gas. That gas forms the glowing coma, the fuzzy sphere you see surrounding comet nuclei in photographs. That glow should increase as the comet approaches the sun, because the heat increases, the vapor increases, and the brightness increases. If a comet dims while approaching the sun, the most normal explanation is distance. But Atlas was not moving away. It was moving closer. The geometry was wrong for a fade. The physics didn't line up. So the first question scientists asked was simple. Why is it fading so fast? 63% isn't a gentle dimming. It's a significant loss of brightness for an object still heading inward. Observers across the world tried to replicate their results. Professionals using high-end equipment confirmed the drop. Amateur astronomers using backyard telescopes confirmed the drop. Observatories in both hemispheres confirmed the drop. It didn't matter who looked, or from where, or with what tool. The numbers matched. The visitor was dimming at a rate that made no sense. The first hypothesis was surface change, an alteration in albedo. If the outer layers of 3I Atlas were darker than its inner layers, then early heating could vaporize the brighter surface ice, leaving behind darker material that reflects less sunlight. Picture a snowbank melting to reveal gravel underneath. From far away, that snowbank would look dimmer, not because it was smaller, but because its surface had changed. This explanation fits some comets, but the speed of the brightness drop pushed this idea to its limit. Albedo can shift, but not usually that fast. The second hypothesis centered on jets, those narrow streams of gas that burst out of a comet when pressure builds beneath its crust. If the jets of 3I Atlas were unusually strong or oriented at odd angles, they might create irregular shadows or disrupt the distribution of dust around the nucleus, causing temporary dimming. But this explanation also raised questions. Jets usually create signatures, flares, spikes, small brightness surges. Atlas was fading too smoothly, too consistently, for jets alone to explain. That led to a third hypothesis, one less obvious but harder to dismiss. Something internal was happening. Something inside the object, structure, density, spin, or composition, was affecting how light left its surface. Maybe layers were collapsing. Maybe cavities were venting. Maybe its rotation was shifting. None of these ideas were proven, but each one pointed in the same direction. This was not a simple comet with a simple explanation. And that realization spread through the astronomy community like a quiet current. To visualize the dimming, imagine you're standing on a coastline at night, watching a distant lighthouse guide ships across the water. You expect the beam to grow brighter as the ship moves toward it. But instead, with each passing minute, the light softens, weakens, and fades, even though the distance between you and the lighthouse is shrinking. It doesn't vanish, it just glows less, as if the keeper inside were turning the dial down instead of up. That's what Atlas looked like from Earth in early November. A lighthouse dimming as the ship comes closer. For astronomers, this behavior wasn't frightening. It was intriguing. But for many sky watchers, including people like you, who follow these stories for the wonder and clarity they offer, the dimming sparked an immediate sense of something is off. You're not imagining it. Something was off. And that difference between expectation and observation became the first thread in a much larger mystery. The dimming also set the stage for everything that followed. Every anomaly in November lines up behind it. Anti-tail, jets, heartbeat, acceleration, all of them sit downstream from the moment the brightness curve began to collapse. If you want to understand the full story of 3I Atlas, you start here in week 1 with the fading light. Because the dimming wasn't just a change in brightness, it was the beginning of a pattern, a signal that this interstellar visitor wasn't going to behave the way comets from our own solar system behave. It was the first hint that you were witnessing something rare. And then, as if the dimming wasn't strange enough, a second mystery appeared. In the second week of November, observers started noticing something even stranger than the dimming. At first, it appeared as just a faint asymmetry in a perfectly normal image, a slightly thicker line of light on one side of the comet's halo. But when more photographs arrived, from more telescopes under more skies, the shape stayed. It sharpened, it pointed, and then the realization settled in. 3I Atlas wasn't just fading as it approached the sun. It was forming a tail that pointed the wrong way. To understand why this was such a surprise, you need a simple picture of how comet tails normally work. Every comet carries dust and gas on its surface. When sunlight heats that material, it escapes into space, forming what we call the coma and the tail. But that material doesn't drift randomly. It gets pushed away from the sun by the solar wind, a constant stream of charged particles flowing outward through the solar system. The effect is as intuitive as watching wind blow smoke away from a candle. No matter which direction the candle is facing, the smoke always goes with the wind. That's what comet tails do. Always away from the sun, always in the direction the solar wind chooses. But sometime around mid-November, 3I Atlas broke that rule. People with small backyard telescopes, using nothing more than careful focus and long exposures, began posting images that showed a narrow, bright streak of light extending not away from the sun, but toward it. Professionals saw it too. The streak wasn't a camera artifact or a reflection. It was real, and it was pointed upstream against the solar wind. This rare feature has a name, an anti-tail. Anti-tails are not fiction. They have shown up before in a few famous comets. Arend Roland in 1957, Comet Ison in 2013, and several others. But they're usually brief, faint, and highly dependent on geometry. To produce an anti-tail, a comet has to shed dust in such a way that the dust spreads into a flat sheet, like a thin pancake orbiting in the comet's orbital plane. When Earth happens to cross that plane at just the right moment, perspective can make the dust sheet appear as if it's pointing toward the sun. It's not truly defying physics, just forming a shape that looks fantastical from one specific angle. But the anti-tail on 3I Atlas wasn't a fleeting illusion. It was strong, clear, stable. Night after night, the same reversed tail appeared in images from different continents, different telescopes, different sky conditions. It wasn't one of those one-evening anomalies that show up briefly and vanish before data can confirm them. It lasted long enough that people began to lean forward in their chairs, open new tabs, reprocess frames, and ask the quiet but honest question, why is this thing behaving like this? Part of the answer lies in the visual itself. The anti-tail wasn't thin and ghost-like. It looked almost like a comet leaning into the solar wind instead of being pushed away by it. Its brightness contrasted sharply against the dimming coma. It didn't fan outward gently. It sharpened into a line that felt organized, a structure, not a wisp. And that alone was enough to make astronomers remark, "We do see anti-tails from time to time, but this one is something else." And while all of this unfolds far away from Earth, you sitting here, listening, can sense the shift in pattern. At first, the mystery was simply the dimming. Why was it fading as it got closer? Now, in week 2, you're watching a second layer unfold, this time in the shape of its tail. Before this moment, you might have forgiven the dimming as some internal process. But a reversed tail? That's something you can see. something you can imagine clearly, something that doesn't require complex physics to feel strange. Amateurs reacted with fascination. Every night it looks slightly different, one observer said as he stitched together a week of images, noticing the tail sharpen, tilt, and lengthen. Professionals reacted with calm curiosity. Anti-tails happen, but this one is bright, structured, and persistent, one astronomer noted while posting comparison images from several observatories. Between both groups, one sentiment began forming quietly. This visitor wasn't simply dimming. It was behaving like a case study you might expect once every few decades. As the anti-tail grew clearer, so did the sense that 3I Atlas was shedding material in a way that didn't fully match the standard models. Was this simply geometry? A perfect alignment between Earth and the comet's dust sheet? Or was something unusual happening in the way the dust was being released, shaped, or compressed? No one rushed to conclusions, but no one ignored the question either. You don't need panic to feel intrigued. You only need to notice that reality is drifting outside the lines of your expectations. For you, listening now, the anti-tail adds another layer of wonder. You clicked because the title suggested something mysterious. You stayed through the dimming because it didn't fit the rule book. And here, with a comet's tail pointing toward the source of the wind that should be pushing it away, you get another moment where your mind whispers, "This is rare. This is unusual. This is one of those things I might never see again." And maybe that's part of the experience. You aren't just learning facts. You're participating in a moment of cosmic strangeness happening above your planet. You're imagining something few people on Earth will ever picture clearly. A tail leaning into the sun, a shape that contradicts instinct, a visitor rewriting parts of the script in real time. And then, beyond the dimming and the strange tale, astronomers began to notice something even more unsettling: a heartbeat. By the third week of November, the story of 3I Atlas had already become strange enough to fill an entire chapter. Dimming when it should brighten, forming a tail that pointed toward the sun instead of away from it. But then, in the middle of all that odd behavior, astronomers began to notice something entirely different. Something rhythmic, steady, and more subtle than any cometary feature most people ever hear about. A signal, not of light exactly, but of pattern, a rise and fall, a repeating pulse. The brightness of 3I Atlas was oscillating, not randomly, not softly, not the kind of flicker you'd blame on clouds, telescope jitter, or small changes in exposure time. The brightness curve climbed and then dropped in an incredibly regular pattern, repeating itself every 16.16 hours, over and over. Each rise took roughly the same amount of time. Each fall matched it almost perfectly. It was as if something in the comet's body, or around it, was breathing in long, slow intervals, on a schedule older than human civilization. At first, the simplest explanation came to mind. Maybe the nucleus of the comet was oddly shaped. Many comets resemble lumpy potatoes or mismatched chunks of ice fused together. If such an object spins, you see more of its surface at some angles and less at others. More surface means more reflected sunlight, and less surface means less. It's a natural, intuitive idea. If it's shaped like a potato, as it spins, you see more or less of its surface. And that creates periodic brightening and dimming. Astronomers have relied on this explanation for decades. It's a standard starting point when you see repeating changes in brightness. But then something happened that shifted the entire discussion. Hubble got a closer look. For most objects, even for many comets, Hubble's resolution is a luxury. Not always necessary, but always helpful. But with 3i Atlas, Hubble's images changed the story. They showed something unexpected. The nucleus of the comet was incredibly small, tiny, dark. A piece of material so dim that it contributed less than 1% of the total brightness. Everything you see in photographs, the glow, the expansion, the structure, comes not from the nucleus, but from the vast surrounding coma of dust and gas. That discovery carved a clean line through the first hypothesis. If the core is almost invisible, then its rotation cannot be responsible for the strong rise and fall in brightness. A potato-shaped rock spinning in the dark cannot create such a large, regular light curve. Something else was doing the pulsing. Something in the coma itself. And that was far more interesting. A natural model began to form. Imagine a region of volatile ice buried beneath the surface of the object. As the object rotates, that patch of ice faces the sun, heats up, and vents gas into space. When it does, the coma surges, growing brighter, expanding, glowing with fresh material. Then, as the rotation continues, the patch moves out of sunlight, cools, and quiets. The outflow slows, the coma dims, and the brightness drops again. The cycle repeats with each full rotation. In that model, every 20,000 kilometers of the coma's size is like a breath, an inhale of light followed by a long exhale of fading glow. If that explanation is right, you're watching a giant, invisible lung, inhaling and exhaling every 16 hours, pumping fresh material into space, not metaphorically, literally. Material launched at 400 to 450 meters per second can travel tens of thousands of kilometers in that time. Enough to sculpt the coma, enough to shape its brightness, enough to create the impression of a living rhythm. But here's the part that sends a soft chill down your spine. One that doesn't scare you, but makes you widen your eyes in the dark. The cycle is perfect. Not roughly 16 hours, not somewhere in the middle. 16.16, over and over again, for weeks, for months, through dimming, through solar wind, through the anti-tail phase, through all the turbulence of early November. It never drifts, it never wobbles. Natural cycles do drift. They wobble, they slow down. Peaks flatten out, and valleys soften as a body evolves. But this one doesn't. Nature rarely keeps perfect time. This object seems determined to. And that precision made even seasoned astronomers pause, not because the pattern suggests anything unnatural, but because it suggests something surprisingly disciplined. If this is just a comet, it's one of the most disciplined comets we've ever seen. That doesn't mean engineered. It doesn't mean artificial. It only means that the universe, once again, is proving that it can create order in the most unexpected ways. Still, when the pattern became undeniable, some people wondered out loud about alternate possibilities. If you wanted to vent gas or adjust course with a regular schedule, it might look a little like this. Not because anyone believes that's the case, but because science is allowed to entertain questions before dismissing them. Curiosity is not the same as conclusion. Speculation is not belief. And a repeating 16-hour heartbeat from an interstellar visitor is interesting enough to at least imagine what else could cause such a thing. For now, the most grounded explanation points to natural rotation, a rotating body with an active vent releasing gas in a consistent pattern. But even that explanation leaves a quiet feeling in the air, the kind that settles in your chest when you realize you're watching something rare, something older than your planet, something that has traveled through interstellar space long enough to develop a rhythm of its own. And now you are listening to it from your bed on a small blue world, while this object from another star system quietly keeps time far above you. The more astronomers watched, the more they began to see echoes of the heartbeat in unexpected places. The jets that sprouted from the coma, the tail that shifted slightly from night to night, the way certain structures in the dust plume brightened and faded in sync with the cycle. Once you start looking for the heartbeat, you begin seeing its fingerprints everywhere. In the jets, in the tail, in the way the whole coma seems to breathe. And with that realization, the story of 3I Atlas shifts again. It no longer feels like a simple comet acting strangely. It feels like a traveler with a rhythm, a visitor marking time, a presence moving through your sky with a pulse you can set your watch by. And if you watch closely, you can see that heartbeat carving patterns into the tail, night after night. By the final week of November, the story of 3I Atlas had shifted from a strange object in the sky to something far more dynamic, almost episodic. Night after night, new images arrived from across the world. Backyard telescopes in quiet suburbs, university observatories perched on lonely hillsides, remote desert setups tracking the sky under cold, still air. Together, they formed a kind of global watch party, each observer capturing a single moment in a changing sequence. If you stitch those moments into a timeline, you could watch the object evolve like a living thing. As the days grew shorter and the nights clearer, amateurs and professionals began posting updates every evening. Here's what Atlas looked like an hour ago. Check what changed tonight. Look at this new feature on the jet. The sky felt less like a place of slow, gradual movement and more like a channel broadcasting something new every night. For a comet, typically steady, predictable, and patient, that alone was unusual. One of the most noticeable nightly changes came from the jets, narrow beams of gas and dust erupting from the comet's coma. On some nights, they stretched straight outward, bright and clean, angled almost toward the sun itself. On other nights, the jets tilted, splitting into branches, bending like delicate strands caught between competing forces. Shifts that usually take days or weeks in typical comets appeared within hours on 3I Atlas. Then came the tail. Comet tails are supposed to be smooth, a long ribbon of dust pulled by solar wind into a gentle arc. But the tail of 3I Atlas didn't behave like a smooth ribbon. It tore, it knotted, it separated into segments like sections of smoke drifting through gusts of wind. Except these gusts weren't random. They seemed to arrive on a quiet schedule, as if each pulse of brightness from the 16.16-hour cycle left its mark across millions of miles. Instead of one continuous plume, observers began noticing repeating patterns, knots, bright pockets, empty spaces. The gaps didn't feel chaotic. They looked almost like a sequence, Each brighter cluster corresponded to what appeared to be a fresh package of material pushed out of the coma during one of the heartbeat's peaks. Each dimmer region matched the quieter part of the cycle. The tail wasn't a line, it was a chain, a string of beads placed across the sky, each bead representing one breath of the comet. If you'd never seen a comet before, you might think this was normal. But if you followed comets for years, or for decades, as many older amateur astronomers have, you'd recognize that this level of structure is rare. Typical comets are messy but consistent. Soft jets, soft tails, slow changes, gentle gradients. But here, 3i Atlas behaved as though the entire object was responding to a metronome, sculpting its own trail beat by beat. And this made the amateur community come alive. For many people, astronomy is a quiet hobby, solitary, patient, introspective. But this comet sparked conversation. Images were uploaded to forums and shared with excitement. Last night it looked like this. Tonight it's different again. Observers compared notes from Arizona, Chile, Spain, Canada. People who had never spoken before were suddenly coordinating observations, lining up their images, matching features, and pointing out changes that only someone looking every single night would catch. And there was something humble and beautiful about that. You, listening now, could sense the energy of those nights. You might even feel a spark of the same curiosity. You didn't need a giant observatory. A modest telescope and a clear sky were enough to join the story. The comet wasn't just being observed from faraway laboratories. It was being watched by people just like you, spread across the planet, following each breath of this interstellar traveler. As the images accumulated, a deeper question began forming in the background. How could a natural object produce changes so rapid, so coordinated, and so tied to a cycle that barely drifted over time? If it were just heating and cooling, the jets might flare in bursts, not in timed intervals. If it were just random outgassing, the tail might shift irregularly, not with such rhythmic structure. No one claimed anything beyond the realm of nature, but the organized patterns made even experienced researchers raise an eyebrow. Still, caution prevailed. After all, comets are notoriously chaotic. They tumble, crack, vent, split, and flare. Some remain dormant for decades before surprising us. Others fall apart as they approach the sun. So the unusual structure of 3i Atlas didn't imply deliberate control. It only reminded everyone that nature can be wild and orderly at the same time. That something can appear sculpted without being sculpted. That geometry, rotation, heat, and dust can dance together in ways that look intentional but aren't. But that sense of organization remained noticeable. If you thought back to the heartbeat from week 3, you could trace its outline here. Each bright jet, each knot in the tail, each shift from one night to the next. Everything felt connected, as though the comet were following its own internal choreography. Jets swelling right as the brightness peaked. The tail nodding when the coma surged. Patterns rising and falling with a rhythm older than our world. Imagine it like a distant machine venting steam at regular intervals, leaving little knots drifting in the plume. Or imagine a volcano that doesn't erupt in one large explosion, but in timed breaths, each exhale leaving a new layer in the ash cloud. You're not being told that 3i Atlas is anything other than natural. but you're being shown why people found themselves drawn to it night after night. It felt active, expressive, almost conversational. By the end of November, the sky had become a series in motion. Each night brought a new frame. Each frame carried a new feature. Something branching, something bending, something shifting, something brightening. The comet didn't wait for weekly updates. It evolved in real time. For a viewer like you, checking each new photograph offered the same anticipation you might feel before opening the next episode of a show you can't stop watching. And as all of this was unfolding in November, the sun decided to throw its own test at 3I Atlas. Near the end of November, just as astronomers were getting used to the nightly rhythm of 3I Atlas, its dimming paradox, its reverse tail, its heartbeat, its shifting jets, the sun stepped into the story. What happened next became one of the most surprising chapters of the entire month. The kind of event that made even veteran skywatchers lean back in their chairs and whisper, "That was not what I expected." It began with a flare, a powerful one. The sun launched a burst of plasma and magnetic fields into space, a coronal mass ejection, the kind of solar weather that can disturb satellites, tug on Earth's magnetosphere, and send auroras across thousands of miles. That blast tore through the inner solar system, expanding outward like a slow-motion tsunami of charged particles. And the path of that expanding wave passed remarkably close to the orbit of 3I Atlas. Think of it as the sun throwing a punch of plasma and magnetic fields across millions of miles. In textbook terms, this isn't good news for a fragile visitor made of ice, dust, and porous rock. Comets are notoriously delicate. They chip, they fracture, they crumble when stressed by heat or radiation. When a flare hits them, three things usually happen. Their surface erodes rapidly, their tails distort or get ripped apart, and their brightness drops sharply from the sudden surge of energy dislodging material. So astronomers braced themselves. Here was a comet already dimming strangely, already showing an anti-tail, already pulsing every 16 hours. How would this interstellar traveler handle a direct hit from space weather? Then the data arrived, and it defied expectations. When the CME washed past 3I Atlas, something unusual happened. Or rather, something didn't happen. The tail didn't shatter into chaos. It didn't whip violently or break into multiple tangled strands the way comet tails often do during geomagnetic disturbances. The brightness didn't collapse. No sudden fading. No dramatic fragmentation event. And perhaps most surprising, no noticeable deviation in its trajectory. In other words, it shrugged off a solar storm that should have left more scars. Images taken before and after the flare showed a structure that was still coherent, still intact, still continuing its nightly rhythm, as though nothing beyond the ordinary had happened. For days after the event, the comet behaved exactly as it had before. Same heartbeat, same shifting jets, same sculpted tail. This resilience sparked questions. Maybe the nucleus was more robust than anyone assumed. Maybe it contained more rock and metal than ice, a dense, reinforced interior rather than a fluffy snowball. Maybe its mass was higher than early estimates suggested, making it harder for the solar wind to push around. Maybe the shape of the nucleus distributed force in a way that let it absorb the flare without cracking apart. All reasonable natural explanations. But when you combine this resilience with everything else that happened in November, the dimming paradox, the anti-tail, the perfect 16-hour rhythm, the organized tail structure, it added another layer to the mystery. Not alarming, not sensational, just strange. Strange in the way that makes you sit quietly and appreciate how little we truly understand about the things drifting between the stars. One astronomer summarized it perfectly. The sun threw a storm at it, and 3I Atlas just kept going. For you sitting at home, listening to this story unfold, imagine it like a fragile snowball sailing directly into a hurricane and simply continuing on its path afterward, unbothered, leaving behind the same quiet trail of breath-like pulses in its wake. Not stronger than the storm, just unaffected by it in a way that feels oddly peaceful. Different scientists reacted differently. Some said, it's just a strong comet, rare, but not unprecedented. Others said, this is one of the strangest natural objects we've ever seen. And a small number, always the smallest group, wondered if there was more to its structure than ice and rock, though none of them claimed anything beyond the boundaries of scientific curiosity. But no matter where they stood, everyone agreed on one thing. The flare was a kind of test, a stress test, a test of character. And 3I Atlas passed that test more cleanly than almost any comet in recent memory. For many astronomers, that was the moment the comet transitioned from an oddity to a precious case study, a rare visitor offering a once-in-a-lifetime chance to understand how objects formed in distant star systems behave when they encounter our sun, a chance to see what survives and what doesn't, a chance to watch the cosmos place pressure on a frozen traveler and observe what cracks and what refuses to. And as November turned toward December, the story didn't slow down. If the solar storm was a punch, the next surprise felt more like a quiet push, because soon after the flare passed, astronomers began noticing something they didn't expect at all. 3I Atlas was speeding up. As November turned toward December, astronomers expected the story of 3I Atlas to begin calming down. After all, it had already passed perihelion, the closest point to the sun, where most comets show their strongest outbursts. Once past that point, the standard expectation is simple: a slow, graceful fading as the object drifts away from heat, away from the turbulence of the inner solar system, and back toward the silence between stars. But 3I Atlas didn't slow down. It sped up. After perihelion, its trajectory began showing subtle but measurable deviations. Nothing dangerous. Nothing that pushed it toward Earth. But enough that astronomers noticed the numbers weren't lining up the way models predicted. A little faster here. A little more drift there. A gentle but persistent push that made even seasoned researchers lean closer to the data and check their assumptions. The acceleration wasn't unheard of, but the amount, the degree, was surprising. Naturally, there is a well-known mechanism behind this kind of behavior. When sunlight heats a comet, the ice on its surface vaporizes and escapes into space. This outgassing produces a small but steady thrust, pushing the comet the same way a tiny thruster nudges a spacecraft. Most comets experience a mild version of this effect. They get a little boost as they warm up. They accelerate slightly as they shed material. But here's the strange part. For a comet to accelerate as much as 3I Atlas did, it would need a significant amount of material escaping. Jets firing harder, a thicker coma, brighter activity, visible surges of dust. It would need to be vigorous, energetic, loudly shedding mass into space. But 3I Atlas wasn't brightening. It was dimming, rapidly. If a comet dims, that usually means its activity is decreasing, not increasing. Less gas, less dust, less outgassing, which means less thrust, less acceleration. But Atlas presented an odd combination, losing brightness quickly, yet gaining speed more than expected. It dimmed, but it sped up. This was one of the most intriguing paradoxes of the entire month. You could almost feel the tension between the two trends. If the comet were shining brightly, a boost in speed would fit neatly into the picture. But this fading visitor was somehow pushing itself harder while giving off less light. So scientists began exploring possibilities. One idea stood out: simple, elegant, and unsettling in its implications. What if 3I Atlas wasn't as heavy as it appeared? What if its density was extremely low, far lower than standard comet models typically assume? Imagine pushing a beach ball versus pushing a bowling ball. A beach ball needs barely a touch to leap forward. A bowling ball, with all its mass, barely shifts. If 3I Atlas were incredibly light, almost fluffy, porous, or even partially hollow, then even small amounts of outgassing could produce significant acceleration. This is the hollow core idea. Not hollow like a shell, not artificial, not engineered, but porous in the way fractal ice structures or extremely delicate snowflake-like formations can be. Some scientists have proposed similar models to explain the odd behavior of Oumuamua back in 2017. Hypotheses involving hydrogen ice, fractal ice, or extremely low-density structures that form under unusual interstellar conditions. These ideas were controversial, but they remain scientifically possible. A hollow or extremely porous structure would allow 3I Atlas to accelerate significantly even if the amount of escaping material is small. It would reconcile the paradox: dimming but speeding up. Less activity but stronger response. A comet that reacts more to gentle forces because it isn't carrying as much weight. It doesn't mean the object is unnatural. It means the object might be exotic, shaped and sculpted by environments we rarely get to study up close. The acceleration had another effect. It nudged the comet's predicted trajectory just slightly off track. Not toward Earth, but away from the earlier projections. Astronomers adjusted their models. They recalibrated their plots. Nothing dangerous appeared. Only the quiet reminder that 3I Atlas was still full of surprises. Even after weeks of observation, it kept offering new puzzles to solve. For you listening now, the emotion this section brings isn't fear. It's fascination. The sense that something in the physics doesn't quite add up, but it adds up in a way that feels inviting rather than threatening. You're following a mystery that rewards curiosity. You're learning something the headlines don't bother explaining. You're stepping deeper into the mechanics of a phenomenon that most people only encounter through brief news bites. Acceleration without enough outgassing. That's a puzzle. And like all good puzzles, it draws you closer, not farther away. The more you understand, the calmer you feel. Strange physics, not strange danger. You begin to appreciate the subtlety of interstellar objects. You begin to see why scientists spend entire careers waiting for visitors like this. You begin to understand why this moment matters. An object that dimmed rapidly, but sped up anyway. A paradox wrapped in dust and ice. And then there was something older. Something from 1977. Something that appeared in the conversations again and again, as astronomers examined the patterns of 3I Atlas, a famous signal, a famous coincidence, not a warning, just a whisper from the past that suddenly felt relevant in the present. And then there was something older, something from 1977, that suddenly felt connected. Before moving toward December 19th, the moment everyone is waiting for, there's one more thread worth visiting. Not because it changes the science, not because it proves anything dramatic, but because it adds a quiet poetic shimmer to the story of 3I Atlas, the kind of cosmic coincidence that makes people who love astronomy smile to themselves in the dark. It begins in the summer of 1977. On August 15th of that year, the Big Ear radio telescope in Ohio picked up a signal unlike anything it had seen before. For 72 seconds, a narrow-band radio emission surged across the telescope's receivers, louder, cleaner, and more well-defined than anything expected from natural background noise. It wasn't chaos. It wasn't static. It was a clear, strong spike, almost like someone slowly turning the volume knob and then turning it back down. When Dr. Jerry Eman reviewed the printout later, he circled the cluster of numbers and letters that represented the signal and wrote a single word in the margin. Wow! It wasn't a declaration of discovery. It wasn't a claim about extraterrestrial intelligence. It was a moment of astonishment, an honest reaction from a scientist who knew he was looking at something unusual, but not yet understood. That scribbled word became a kind of legend. Generations of sky watchers and radio astronomers would refer to it simply as the WOW signal. Not proven, not repeated, but remembered. Even now, almost 50 years later, the story still carries a quiet charm. Not because the signal was definitive, but because it was fleeting. A moment of wonder etched into the noise of the cosmos. And this is where the coincidence begins. The WOW signal came from a region of the sky near the constellation Sagittarius, specifically from a narrow area inside what's sometimes called the Big Ear beam. It was not pinpointed to a single star or object, but to a general direction, a small slice of sky far away from Earth, deep toward the center of the Milky Way. When astronomers plotted the path of 3I Atlas across our sky earlier this year, something interesting appeared. In 1977, the comet, far out in interstellar space at the time, would have been located in roughly the same broad region of sky from which the WOW signal arrived. Not in the same place, not crossing the exact coordinates, but near enough to spark a moment of recognition in anyone who has followed both stories. Two moments, decades apart, one radio signal, one icy visitor, both touching the same general backdrop of stars. And here is the important line, the one that keeps the story grounded. This is not evidence. It's just an interesting cosmic rhyme. The universe is enormous. Patterns overlap. Paths cross. A coincidence of direction does not imply connection. But sometimes, knowing the sky has echoed with two different mysteries in the same region gives you a certain feeling, a gentle nostalgia for the unknown. It's the same sensation that makes people fall in love with astronomy in the first place. The sense that the cosmos has chapters, and that you're living in one of them. And maybe that's the point. To appreciate the sky is to appreciate these moments. Not because they demand answers, but because they invite reflection. They remind you that wonder doesn't need certainty to be meaningful. Like two notes in a song that happen to match, even if they're from different instruments. Or like two stories separated by half a century that happen to cast their shadows in the same corner of the night. You don't need to leap to conclusions. You don't need to entertain wild theories. You only need to enjoy the coincidence, to let it add a little color to the quiet mystery of Three-Eye Atlas drifting across your December sky. In science, coincidences are invitations, not conclusions. They pull you a little closer to the unknown without pushing you toward fear. And if you're listening to this now, lying in bed, ready to drift off, the wow signal becomes less a question and more a reminder. The universe has a way of surprising us softly. And whatever that 72-second signal was, natural, artificial, random, or something we simply haven't explained yet, it belongs to the past. Your next real data point belongs to the present. And now, we finally look toward the date everyone has been waiting for, December 19th. As the calendar turns to early December, something quietly extraordinary happens. The long arc of the past month, the dimming, the anti-tail, the heartbeat, the jets, the resilience, even the post-perihelion acceleration, begins to point toward a single stretch of time, a window, a moment in the sky where everything aligns. Geometry, light, distance, and observation. Astronomers have a name for it, spoken almost with a sense of reverence: the golden window. This window runs from now, these first days of December, until the 19th. And if you're listening to this on the 5th, you are right in the middle of it. These 2 weeks are the best opportunity you will have in your entire lifetime to observe an interstellar visitor this clearly, this consistently, and this meaningfully. Everything about its position, its orientation, and our line of sight comes together here in this narrow slice of the month. Why is this window so important? 3 factors converge at once: the angle between the comet and the sun, the clarity of Earth's night sky position as our planet rotates through its December arc, and the way Three-Eye Atlas reflects what little light it still produces. Earlier in November, it was changing shape so quickly that many observatories struggled to catch consistent patterns. Later in December, after the 19th, the brightness will drop rapidly, making fine details harder to detect. But right now, everything is optimal. This is the moment when the coma is large, but not overwhelmingly bright. The jets are active, but not smearing into a blur. The tail is long, segmented, and perfectly positioned for imaging from multiple hemispheres. Even the sun's glare is at a cooperative angle, not too sharp, not too shallow, letting researchers peer into structures that would otherwise be washed out or lost in background noise. In other words, from now until December 19th, the universe opens its curtains. And because of that, every major observatory you can name is watching. Telescopes in Hawaii suspended high above the Pacific. Arrays in Chile, standing under some of the cleanest skies on Earth. Instruments in the Canary Islands. Even smaller sites across Europe, Asia, and North America. For the first time in decades, there is global alignment around a single mysterious object whose behavior refuses to behave by standard rules. It isn't just the big observatories. Amateur astronomers, the same ones who helped reveal the heartbeat, the tail segments, and the nightly jet changes, are preparing too. Many have already begun imaging the comet every night, stacking frames, comparing patterns, updating forums with notes like, "Tonight's pulse looks stronger," or "The anti-tail is more defined than yesterday." You can feel the sense of community around it, a kind of shared anticipation, the same way people monitor a launch, a supernova, or the return of a rare meteor shower. So, what do astronomers expect during the golden window? First, the heartbeat should be clearer than ever. As the coma cools slowly and thins slightly, the 16-hour cycle may appear in sharper relief. Brightness waves might ripple more noticeably through the jets, leaving trails that trace each pulse like the seconds on a clock. If you've followed the story so far, you'll recognize those patterns instantly. You'll see them the way an experienced observer sees Jupiter's storms or Saturn's rings, features that tell a story if you know how to read them. Second, the segmentation in the tail could become even more visible. As the comet moves farther from the sun, the dust packets created by each burst of outgassing may drift apart more cleanly. What looked like faint beads in November could stretch into long necklaces of structures, each one representing a single exhale of the comet. Third, the jets themselves may shift dramatically. Leaving the sun's intense heat behind often causes jets to angle, twist, or even shut off temporarily. Some might divide, others might fade, new ones might open. The comet will be in transition, and transitions are when the most interesting details appear. And yet, through all this anticipation, the tone remains calm. This golden window is not a countdown to danger. It's a countdown to clarity. Nothing about 3I Atlas poses a threat to Earth. There is no hidden risk, no collision path, no secret NASA memo, no looming catastrophe sealed behind scientific terminology. The only thing approaching us is information. The only thing coming closer is understanding. Whatever the mystery is, natural or unusual, we're about to get the clearest view of it. Not because it will do something dramatic, but because this is the moment the sky allows us to see it best. It's like watching the finale of a cosmic play unfold, quietly, slowly, without rush or noise. A shimmering act written across millions of miles, performed by an object that has traveled for ages through interstellar cold and is now spending a brief, luminous moment in our neighborhood. This is the time to observe it, to appreciate it, to enjoy the long, deliberate breath of knowledge that comes with these rare alignments, and to remember that even the most extraordinary events in astronomy often pass without fanfare, without danger, without urgency, just serene beauty drifting across your night sky. And the closer we get to December 19th, the more the fear fades and curiosity takes over. The more the noise of speculation dissolves into the quiet certainty of observation. The more this interstellar visitor feels less like a question mark and more like a reminder of how wide the universe truly is. You'll never again be this close, not just to the object, but to the mystery. And now, let's close this night the way the universe closes its stories, quietly. Before you close your eyes tonight, let's take one last quiet walk through everything you've just traveled across. You began this journey in early November, when the first unexpected dimming of 3I Atlas caught the attention of astronomers around the world. A visitor from another star system, growing fainter as it approached the sun, behaving the opposite of what nearly every comet in living memory has done. From that first anomaly, the story expanded piece by piece until it became something far richer than a simple scientific update. It became an experience, a slow, unfolding mystery written across the sky. You followed the dimming to the appearance of an anti-tail, a tail that leaned into the sun instead of away from it, sculpted by geometry and dust into shapes that defied intuition. Then came the heartbeat, that steady 16.16-hour rhythm, rising and falling in the comet's light curve. You learned how it pulsed like a giant invisible lung breathing into space. You traced that beat into the jets, into the tail, into the nightly changes that turned late November into a cosmic time lapse. You watched the sun throw a flare toward this fragile interstellar traveler, and you saw Atlas withstand it with surprising grace. You saw it accelerate when it should have slowed. You revisited the quiet poetry of the 1977 WOW signal. And finally, you arrived at the golden window, the days between now and December 19th, when the universe opens its curtains just long enough for Earth to catch the clearest view it will ever have. And now, the story settles. Not because it ends, but because you've reached the part of the night where questions give way to calm, where curiosity softens into quiet understanding, and where the only thing left to do is rest. Here in Sleepy Universe, we don't run from the unknown. We listen to it. We don't panic when something behaves strangely in the sky. We observe it. We understand it. We place it gently in the larger tapestry of the cosmos, where every mystery eventually finds its place. Because the truth is simple, and it's the truth you deserve to hear as you settle your breathing and let your mind drift. Tonight, you are safe. Nothing out there is coming to harm you. Nothing in this story is a threat to your world. Nothing hiding behind scientific jargon is waiting to surprise you in the dark. The universe is vast, yes. Mysterious, yes. Occasionally humbling, absolutely. But dangerous to you? Not tonight. Not from this. Not from an interstellar wanderer quietly gliding past your corner of the sky. The title promised a terrifying mystery, but terrifying doesn't always mean dangerous. Sometimes it means humbling. Sometimes it means beautiful in a way that makes you realize how small your worries are compared to the billions of stars glittering above you. Terrifying means your world is part of something bigger. Terrifying means you're connected to a universe that doesn't need your permission to be extraordinary. Terrifying means awe, the kind that softens your shoulders, loosens your breath, and reminds you that existence is vast, ancient, and endlessly surprising. As you lie there listening, picture 3i Atlas now. Far from your city lights, drifting through the black, its glow slowly fading into the quiet dark. It is moving away from the sun, cooling, shedding less material, its heartbeat softening with distance. The solar wind that once stirred its tail is flattening out again, blending back into the endless silence between planets. Picture that vast wind, carrying dust, particles, and light, fading into the background like the long exhale of a universe settling into sleep. Picture Earth beneath it all, turning calmly in its orbit. The oceans breathing in slow tides, the continents cooling under winter air, the atmosphere wrapping you like a thin, perfect blanket. Tonight, nothing disturbs your sky. Nothing rattles your world. everything is in its place. And as 3i Atlas drifts onward, the glow you once watched so closely becomes a faint whisper, a final reminder that curiosity will always lead you somewhere unexpected, but rarely somewhere frightening. The only real fear, after all, is the fear of not looking up. Curiosity turns fear into understanding. It turns nervous questions into quiet confidence. It turns the unknown into a companion rather than a threat. And look at you. Most people won't spend 90 minutes learning about a distant comet. Most won't follow each anomaly, each pulse, each shift in the tail. Most won't stay awake to understand something simply because they want to know the truth. But you did. You know more tonight than most people on this planet. Not because you memorized data, but because you cared enough to listen, to understand, to look up and say, I want to know what's really happening. And that desire to understand rather than imagine the worst is what makes astronomy such a comforting companion. Because the more you learn, the safer you feel. The more you see the universe for what it truly is, the less room there is for fear. Knowledge is the quiet lamp you carry into the dark. And tonight, that lamp is glowing softly beside you. So now, let the world around you dim a little. Let your shoulders sink into the mattress. Let your breath match the slow rise and fall that carried you through this story. Let the questions drift. Let the universe hold them for you tonight. You don't need to chase answers. You don't need to keep thinking. The mystery will still be there tomorrow. The sky will still be waiting. The golden window will still be open when you wake. Your world is calm. Your room is quiet. And the universe, vast as it is, has no intention of troubling your sleep. So let your eyelids grow heavy. Let the dark settle gently around you. Let the last thoughts of the day float away like dust leaving a comet's surface, drifting slowly into the night. Fear is just respect for the unknown. And tonight, you have nothing to fear. You are safe. The universe is quiet. And tonight, you can rest. You are safe. The universe is still quiet tonight.